Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 38 of Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I'm Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. Over the course of the last 18 months, Gardeners of the Galaxy has heard from scientists working on how to grow plants in space or on other planets. We've heard about the challenges they and the plants face, and the hard work and ingenuity that's created some amazing successes, from adding to our fundamental understanding of how plants work, to allowing astronauts to nibble on fresh radishes and chilies. But as every gardener here on Earth will testify, things don't always go according to plan, and so I thought that for this episode it would be fun to hear some stories of off-nominal plant experiments when things have gone wrong. An astrobotanical blooper reel, if you like. Before we get to that, I'd like to say thank you to my Patreon supporters for their continued support for the show. From just £1 a month you can join our community of space gardeners and help me keep the astrobotany anecdotes flowing. And now, if you'll join me in the time machine, we'll start with a quick trip back to 2015, when the entire British nation was eagerly awaiting the moment that Tim Peake would blast into space. In May 2015, the UK Space Agency and the Royal Horticultural Society unveiled the Space Plants experiment that would become synonymous with Tim Peake's Principia mission to the International Space Station. The British public was elated that a second British astronaut would finally be blasting into space, and the UK Space Agency was determined to capitalise on that excitement and develop educational activities that would encourage a new generation of children to consider careers in science and technology. The biggest of these was rocket science, a programme that would send rocket seeds, arugula, to the ISS during Tim's mission, then return them to Earth to be grown by schoolchildren alongside seeds that had never left the planet. And so rocket science was announced with much fanfare at the Chelsea Flower Show, the UK's biggest annual plant extravaganza, attended by the royal family and every celebrity that enjoys wearing a posh hat. The Queen herself visited the rocket science show garden, which demonstrated the importance of plants in space. Divided into 4 zones, it used interactive displays to show past, present and future plants in space, explaining the important role scientists play in helping plants grow in inhospitable conditions. It showed how space exploration helps solve problems on Earth, and even the plants astronauts need to survive long-duration missions, including 10 food crops that scientists at the Melissa Project have picked for closed-loop life support systems. The spectacle was completed with a real-life Mars rover, and ESA scientists were on hand to talk about their work. During a visit to the exhibition, the UK Minister for Universities and Science, Jo Johnson, said, "Britain's space industry is going from strength to strength, and for this to continue it is right we inspire the next generation of scientists and engineers. Rocket science is doing just that by giving thousands of schoolchildren the opportunity to play a part in Tim's mission to the International Space Station, while learning new skills in a fun and unique way." In addition to the flower show, Tim Peake recorded a video introducing the Rocket Seeds project and inviting UK schools to sign up to take part. With all this excitement, lots of schoolchildren and British people in general logged on to watch the seeds launch into space on June the 28th, 2015. It didn't hurt that the launch took place mid-afternoon, a good time to sit down with a nice cup of tea and a biscuit. And it all went swimmingly well for the first 2 minutes of the launch, but just before the first stage was due to separate from the second stage, the rocket exploded. The Dragon CRS-7 cargo capsule was ejected from the exploding launch vehicle, but its onboard software wasn't programmed for this contingency, and so it didn't deploy the parachutes that would have brought it safely back to Earth. The capsule is assumed to have crumpled and broken up when it impacted the ocean. So, rocket science didn't get off to a good start, but as the UK Space Agency and the RHS were at pains to point out, these things happen in spaceflight, and they had been aware that losing the payload was a possibility. Within an hour of the failed launch, they were on the phone with ESA to make fresh plans. On the 1st of July, the RHS announced that Tozer Seeds had agreed to supply a second batch of rocket seeds, and the discussions for a new launch were ongoing. The second batch of seeds launched on the 2nd of September on a Soyuz rocket with ESA astronaut Andreas Mogensen and arrived safely at the ISS shortly afterwards. The timetable for the rocket science program was unchanged, with the seeds coming back to Earth for planting as planned. 600,000 UK schoolchildren got their first exciting taste of astrobotany and discovered that the space-flown seeds hadn't been changed much by their exciting adventure. As I mentioned in the last episode, Apex-07 was one of 4 plant experiments delivered to the International Space Station by Cargo Dragon just before Christmas. Apex-07 uses Arabidopsis plants to examine how the spaceflight environment affects gene expression in plants. Previous research has shown that microgravity affects which genes turn on or off, which proteins are present and in what amounts, and the modifications made to those proteins. These processes are all controlled by RNA, and Apex-07 analyses the role of RNA regulation on gene expression during spaceflight in the roots and shoots of plants. On the 28th of December, the ISS crew set up the Apex-07 experiment in both of the veggie growing chambers, inserting 30 Petri plates in each unit. The experiment was scheduled to run for 12 days, after which the crew harvested the plants and froze them in the -80 degrees centigrade freezer, ready to return on Dragon later this month. If you're getting a feeling of déjà vu, that's because this is the second time that the Apex-07 experiment has flown on the ISS. Its first trip was in June 2021. In a talk she gave in October 2021, Principal Investigator Dr. Sarah Wyatt from Ohio University explained the painstaking work involved on the ground to get Apex-07 into space. Step 1 is the grant proposal, the essential first step in any science experiment when you have to convince someone else that it's worth doing and to give you the money to do it. Once the check is cleared, you can move on to Step 2, the definition phase. This is the point where you translate the experiment you had on paper into one that will work in real life. At the point at which the team were ready to do this for Apex-07, COVID struck and the lab had to close. Grad student Al Myers, he's now a postdoc, took everything home to work out how they were going to grow their plants in space. This is a crucial step for spaceflight experiments, as you have to be as sure as you can be that they'll work when NASA takes all the trouble to launch them into space for you. So now that all of the experiment parameters are well defined, it's time to give it a go in a mini trial called the Science Verification Test, SVT. This is step 3 and it takes place in a lab at Kennedy Space Center, which at the time was shut down, operating with essential personnel only. Al Myers tested plating up the seeds into their Petri plates, which is a painstaking process done by hand, and then the team ran the experiment to collect data and prove that their techniques work and produce the results they want. Once NASA has confirmed they're happy with the SVT results, then it's back to Kennedy for Step 4, the Experiment Verification Test, EVT. This is essentially a dress rehearsal, running the complete experiment on the ground to make sure it works. So for this one, Al has to hand sew 60 plates with Arabidopsis seeds. If everything is hunky-dory, your experiment is then cleared for flight, and it's back to Kennedy Space Center to go through the whole preparation again, only this time the plates are all individually packed in foil, put into cool bags, and handed over to the payload people who put it on the rocket. And you get to watch the rocket launch your experiment into space. And the launch of Apex-07 went well, and it arrived safely at the International Space Station. And the crew there set up the experiment in veggie and tended it for 12 days and then spent 2 hours painstakingly removing each plate, harvesting the plants, wrapping them in foil and putting them in the freezer until their trip home. And later on the crew prepared Dragon for its return to Earth and transferred the Apex-07 plants from the ISS freezer to the freezer on Dragon, and Dragon undocks and starts its return journey. Meanwhile, back on Earth, it's Friday afternoon and Dr. Wyatt is taking a break at the pool. When she emerges, it's to urgent messages from NASA. Of the 60 sample packets that were so painstakingly harvested and frozen, only 36 of them made it onto Dragon. NASA knows this because the other 24 have been found floating around the ISS at ambient temperature. At this point, the experiment is compromised and there's no point returning the missing samples to Earth. Not enough samples have been returned to complete the experiment, so NASA say they will refly the entire experiment, which means the Apex-07 team have to go through the whole process again. And that's the experiment that's just taken place. Fingers crossed they'll be able to get some results from all of their hard work this time. Dr. Imara Pereira at the University of North Carolina is involved with two of the plant experiments currently on the space station, Apex-07 and MVP Plant-01. These experiments are a continuation of her work to characterise seedling responses to microgravity and the spaceflight environment. In 2016, Dr. Pereira was principal investigator for a plant experiment running on the ISS and was no doubt watching as NASA astronaut Kate Rubins prepared to retrieve her plant samples from the European Modular Cultivation System, the EMCS. By then, the EMCS had been on the space station for a decade, delivered by Space Shuttle Discovery in July 2006 and installed by ESA astronaut Thomas Reiter in the Columbus module. The EMCS was designed as a facility for studying plant biology in space and could control temperature, atmospheric composition, water supply, lighting, observation, and gravity. To create artificial gravity conditions, the EMCS contained two centrifuges, which could be independently programmed to provide anything from 0.001 G to 2 G. Notable experiments to have taken place in the EMCS, which was decommissioned in 2018, include TROPY and GRAVI. Anyway, the experiment running in the EMCS that day was called Plant RNA Regulation, or PRR. PRR was using the model plant Arabidopsis to study the roles that ribonucleic acids, that's RNAs, play in plant responses to spaceflight during the early development of plant roots and shoots. There were two identical PRR experiment runs. For each, the ISS crew loaded cassettes with Arabidopsis seeds into the EMCS. ESA controlled the EMCS from the Norwegian User Support Operations Centre, and staff there initiated the experiments by sending a command to the EMCS to hydrate the seeds and start the germination process. Over 6 days, half of the samples were exposed to microgravity and the other half to artificial gravity in a centrifuge. At the end of the experiment, an astronaut would have to remove the seedlings and freeze them to be returned to Earth for analysis. So that's what Kate Rubins is about to do on the space station with controllers in Norway looking on. The EMCS is computer controlled, and to retrieve the seedlings, Kate needed to log onto a laptop, but it's asking her for a password she doesn't have. In Norway, people are flicking through the paperwork to find the password. They don't have it either. Now, this is a time-sensitive operation. To preserve the genetic information in the plants, they need to be in the freezer within 45 minutes from when the centrifuge stops spinning. After 30 minutes of frantic phone calls and rising tension, the Norway controllers are able to take remote control of the EMCS and unlock the centrifuge. Kate was then able to harvest the seedlings, pop them in the freezer on time, and save the experiment. Phew! Meanwhile, back on Earth, NASA Mission Control has found the source of the problem. It turned out that all of the computers on the ISS had recently been upgraded to Windows 7, and the password reset had been an unexpected consequence of the upgrade. And now, if you can all squeeze back into the time machine, we're going to travel back to the era before the International Space Station was built. In 1996, NASA astronaut Shannon Lucid spent 6 months on the Russian Mir space station. This was part of the 4-year Shuttle Mir program, a space-based exchange program that also saw Russian cosmonauts fly on American space shuttles. It allowed America to learn more about long-duration spaceflight and develop cooperation between two of the spacefaring nations who were planning to build the International Space Station. One of the experiments that Lucid conducted on Mir was the first attempt to grow plants from seed to the point where they flowered and set seed successfully in space. Doing so would prove that there are no insurmountable problems to plants carrying out their full life cycle in microgravity, which is a key requirement for long-duration space missions and bioregenerative life support systems. So Lucid was tending a crop of dwarf wheat growing in the Svet greenhouse. In an article she wrote for Scientific American, she described planting wheat seeds into a bed of an absorbent material called zeolite. As a quick aside, I recently discovered that gardening that way was described as zeoponic, which was a new word for me. The Svet greenhouse was computer-controlled, and that took care of lighting and watering. Lucid would monitor the growth of the wheat and take photographs every day to document it. After about 40 days, she noticed that seed heads were forming, but she left Mir before they ripened. It was therefore her replacement, John Blaha, who had the honour of harvesting over 300 seed heads and packing them for their trip back to Earth. And everyone was very excited, but the scientists at Utah State University who examined them found that the seed heads were empty. No seeds had been formed. Evidence suggested that ethylene gas in the atmosphere on the space station caused the problem. Although ethylene isn't harmful to humans, it's a plant hormone that can interfere with seed production. And so it fell to British-born astronaut Michael Foale, who arrived on Mir in 1997 to complete a seed-to-seed experiment. His predecessor, Jerry Linenger, suffered a bumpy ride on Mir as a backup oxygen generation device caused a fire, the space station nearly collided with a Progress resupply ship, and the crew battled various system failures, including a total power cut that resulted in a loss of attitude control. Foale set up home in the Spectre module and began carrying out his experiments. His seed-to-seed experiment, also in the SPEC greenhouse, involved a specially bred variety of brassica from Wisconsin fast plants. As the name suggests, these varieties are fast-growing dwarf plants bred for scientific experiments. They will be familiar to lots of school kids across America. After his return to Earth, Foale described the painstaking process for setting up the experiment, which began with locating all of the necessary equipment left over from the previous expedition and setting up the greenhouse. He then had to individually remove 52 brassica seeds, and you know how tiny they are, from sticky tape with tweezers and nestle them into wicks placed on the zeolite material. Then there was the tricky balancing act of giving the plants enough water without overwatering. And when the seeds germinated, half of them were upside down. Foale had planted them too deeply for light to penetrate, so without gravity they couldn't orient themselves. Once he had helped them point in the right direction and they could see the light, they were fine and grew towards it. Foale had to monitor the atmosphere around the plants, and when they started to flower he had to manually pollinate them with a bee stick, essentially a toothpick with the fluffy end of a bee attached to it. And after about 6 weeks, seed heads formed and looked as though they contained viable seeds. And when it was time, Foale harvested the plants and collected them in a glove box, where he had the task of collecting tiny seeds floating around in microgravity. It took him about 3 days to harvest the crop and store the seeds. Some were stored with a desiccant for 50 days, ready for replanting in space. The rest were stored for return to Earth. And then it was time to run the whole experiment again, this time sowing the space-grown seeds to see if they would successfully grow. So Foale laboriously repeated his sowing exercise and set the whole thing running. However, at this point in the mission, things took a dramatic turn when a Progress cargo vessel collided with the Spectre module and ruptured the hull. With the space station depressurising, the crew cut the cables running to Spectre and closed the hatch, sealing it off. The crew were then tasked with stabilising the space station, eventually using a special hatch to run cables from systems in Spectre to the rest of Mir. However, the Spectre module remained unusable, and Foale lost most of his personal belongings and a lot of his scientific supplies. Fortunately, the SPEC greenhouse was housed in the Crystal module and was one of the few experiments Foale could continue to work on. At the time of the collision, the plants were left in darkness for 72 hours, but although they were smaller and had a higher percentage of undeveloped seeds, they did grow and they did produce a second generation of seeds in space. These were then brought back to Earth in triumph, where 89% germinated and grew and resulted in plants that were just a little bit less vigorous than their Earthbound compatriots. It was also obvious that having plants to tend and look at was a considerable psychological benefit to the crew at a time of extreme stress. That's it for this episode. If you've got a story to add to the blooper reel, then do get in touch. In science and gardening, things don't always work first time, and that's okay, because we can learn from the process and try again. You can get in touch at Orbital Gardens on Twitter and Instagram, and Gardeners of the Galaxy has its own Facebook page. I'll be back with a new crop of astrobotany in a couple of weeks. In the meantime, don't forget you can sign up to support the show at patreon.com/Gardeners of the Galaxy. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control. We are confirming termination of your signal. Unfortunately, we have also lost your movie requests, so we have picked you The Martian and Frozen. Uplink commencing now. Mission Control out.